This is case of persistent pulmonary hypertension of newborn with ASD and PDA. Image you see, this is apical fourth chamber view. This is not the classical image. Image is little bit right ventricle oriented so that you can easily see tricuspid registration jet. This is TR jet, mild to moderate. This is the place where the ASD is seen. This is mitral valve and this is left ventricle. So modified apical fourth chamber view. Mainly uh, probe is directed in the way that RA and RV is clearly visible. The next image is again you see the same TR jet. Now see image by this is main pulmonary trunk, this is right pulmonary artery and this is PDA. PDA orientation wise the most lateral one is PDA. First right pulmonary artery, left pulmonary artery is not seen in this image in this view, but left pulmonary artery location wise is here and the most lateral one is the PDA. You can see alternatively blue and red color. Blue means from pulmonary artery to aorta, red means from aorta to pulmonary artery. So red is color and blue is the reverse color, that means flow is reversing. What is that? Means flow has reversed because of raised pressure inside pulmonary arteries. So whenever pressure exceeds in pulmonary artery, flow becomes blue. When the pressure is less in pulmonary artery compared to aorta, then flow is red. Normally we see red in color because aorta has usually more pressure compared to pulmonary circulation. So in this image what you see, flow, bidirectional flow in PDA. So whenever you see the bidirectional flow in PDA, that indicates there must be raised pulmonary circulation pressure. That means right ventricular system has got more pressure. That is a flow reversing. Again see the same thing, PDA with flow reversal. PDA with flow reversal, bidirectional flow in PDA. This is size of ostium secundum ASD. This is pressure gradient across tricuspid valve, where the velocity is 2.97 meter per second and peak gradient 35 millimeter of mercury. So whenever you have to add RVSP, means this velocity square of 4 into velocity square of TR jet plus right atrial pressure. So RVSP minus right atrium, that is the pressure gradient across the tricuspid valve, that is peak velocity and peak gradient of TR jet. So whenever you want to calculate right ventricular systolic pressure, then you have to add RA pressure to this one. RA pressure is calculated by looking at the size of IVC. In case of adult, you know the formula. When the size is more than 2.1 centimeter and respiratory variation on sniffing less than 50%, that means pressure is quite high. Pressure is in between 10 to 20. So you have to add 10 to 20 in that case to TRJ, 4 into TRZ square. RABC means right atrium plus pressure, right atrial pressure plus 4 into velocity of TRZ square. That is the formula. So this is the case of persistent pulmonary hypertension of newborn. The baby is only 2 days old. So we call it persistent because the pulmonary pressure is higher in case of utero, that is inside mother, but when baby comes outside, pressure should gradually decrease but in this case it has not decreased, it has remained same, it has persisted. That is why we call it persistent pulmonary hypertension of newborn, because pressure has persisted, yet still the pressure in right atrium, right ventricle and pulmonary circulation is more compared to left side. That is why the flow is bidirectional in PDA. So ultimately we came to know whenever you find bidirectional flow in PDA or ASD or VSD, try to rule out persistent pulmonary hypertension in case of neonate, that is child with age less than 30 days. That is the point to know. This is the size of PDA. PDA size wise 0.514 centimeter, that is around 5 millimeter. You can say it is moderate size. Here you see the size of left atrium versus aorta. The size of left atrium versus aorta is more than twice. That means the PD of severe nature. Again, this stem second ASD. This is TRZ. This is the velocity of pulmonary ejection jet. Here the pulmonary artery and diastolic pressure is 16 millimeter mercury. That is close to moderate to severe pulmonary artery hypertension. So basic fact we came to know in this video is, if the flow is bidirectional, baby is newborn, TRZ, try to calculate right ventricular systolic pressure by just measuring 4 into velocity square of TRZ, the peak velocity of TR, tricuspid registration. Obviously, whenever you want to measure the peak velocity, you have to measure the most turbulent flow. Even TRZ, you see this is TRZ. Where is the most turbulent? That is turbulent means color mixing. That part must be interrogated with this cursor line. So whenever you find this this is central jet, no problem in calculating TRZ, peak pressure, peak velocity. But when you will find eccentric jet, in that case you have to find the most turbulent part of the jet. You have to align the cursor across the most turbulent part, because that will give the highest velocity. Here the highest velocity has to be measured so that we can calculate right ventricular systolic pressure. I have already said the pressure gradient across right ventricle and right atrium. That is the peak velocity of TRZ gives you the pressure gradient. 4 into velocity square is the pressure gradient. So to calculate right ventricular systolic pressure, you have to add this velocity, this peak gradient to the right atrial pressure. Right atrial pressure is calculated by size of IVC and respiratory variation, or you say by sniffing test, how much IVC collapses on sniffing test. So if collapse is less than 50, that is abnormal. When collapse is more than 50, that is normal. When size is more than 2.1 centimeter in case of adult, then that is abnormal. Less than 2.1 centimeter in adult, that is normal. But in case of children or neonate, you cannot know what is the should be actual size. Then we compare it with the aorta, because aorta is also seen along IVC. So we just compare with aorta. If size is more than aorta, then it's dilated. Or you can also find out if right atrium, right ventricle dilated, that means pressure is raised, or pressure is also raised on the right atrium side. So in that case you have to add up to 20 millimeter. If chamber size everything is normal, right atrium, right ventricle size is everything is normal. The size where RE and RV normal, IVC normal. In that case just you have to add up to 5. That is mean is 3. 0 to 5 means mean is 3. You have to add right atrial pressure should be around 3 millimeter of mercury. So RVSP equal to 4 into peak velocity of TRZ square plus right atrial pressure. That is RVSP. If there is no pulmonary instrument, that RVSP equal to pulmonary artery systolic pressure, because same pressure also remains in the pulmonary artery circulation. So whenever TRZ velocity is very high, that means RVSP is very high, right ventricular systolic pressure is high, that is pulmonary artery pressure is also high. That is why we call it pulmonary artery hypertension. Thank you.